2003 or M may have been ejecting matter, which often happens with comets, but there was one catch: the object didn't look like a comet. It had no tail or visible gas cloud. It was just a tiny, glowing dot, similar to an ordinary asteroid. At first, scientists thought that 2003 or M was just only a single mystery, but in 2017, last year, the telescope discovered that 2003 or M is just a single mystery. Another strange object was spotted, this time from outside our solar system. It was Amua Mua. It also looked like an asteroid, but its trajectory changed as it was like gas was coming out of him. The similarities between Amua Mua and 2003 or M led researchers to think that perhaps 7 more such strange objects would be discovered in our solar system by 2023. And these discoveries were enough to give this new type of object the name dark comets. Now scientists have enough data to start noticing patterns and learn more about their characteristics. They identified 2 main groups of objects: dark comets. The first group, called outer dark comets, are larger and range in size from hundreds of feet or even more. They move in long elliptical orbits like traditional comets that come from areas close to Jupiter. The second group of inner dark comets is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun near planets such as Earth, Venus, and Mars. The main question these days is where dark comets come from and whether they could be the remnants of larger bodies that have broken apart. History of the solar system. What if they had delivered the ingredients for the origin of life on early Earth? As soon as we study dark comets better, we will be able to find out if they contain materials such as ice or organic compounds. And indeed, some researchers are confident that dark comets may contain, or when, according to several studies, some asteroids in the asteroid belt, the area between Mars and Jupiter filled with rocky debris, may have ice under their surface, and this ice from the asteroid belt could fall into the near future space. In other words, it could be the path that water takes to reach our planet. So far, no one is claiming that dark comets definitely brought water to Earth, but there may be another mechanism for moving ice from one part of the solar system. On the other hand, the study also points to a connection between dark comets and a group known as Jupiter family comets, which are comets whose orbits are strongly influenced by Earth's gravity. Jupiter often attracts them to the Sun, which makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, usually within the ice line, so close to the Sun that any ice on the asteroid's surface would immediately turn from solid to gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. As they approach the inner solar system, their ice also begins to turn from solid to gas, creating a cloud called a coma or tail. Dusty and gaseous dark comets blur these definitions. They look like rocky asteroid objects without a coma or tail, but their behavior is typical of comets, and these are small non-gravitational accelerations that occur when ice turns into gas, giving an analysis of 7 known dark comets. Astronomers estimated that from half to 60% of all objects, near-Earth objects, may belong to this mysterious category, and since dark comets most likely originate from the asteroid belt, ice probably exists even in those areas of the belt that were previously considered too deep. Objects approaching Earth, such as dark comets, do not stay in the same orbit forever. The near-Earth environment is unstable, and objects usually stay there for about 10 million years have passed since the solar system turned over 4.5 billion years old, which means that now astronomers have used computer models to simulate the motion of objects under that influence of non-gravitational accelerations. They trace the trajectories of these objects for 100,000 years and discovered that many of them ended up in the same regions. Where we are now, find dark comets today. Remember the 2003 or M space rock, which was the first to be named a dark comet, which gave a particularly interesting clue. Its elliptical orbit brings it closer to Earth and then to Jupiter before returning to Earth. We can say that this trajectory corresponds to what scientists would expect from a comet of the Jovian family, an object that was probably knocked out of its original orbit. However, most of the other steady dark comets seem to have come from the interior asteroid belts located closer to Mars. Dark comets are often small and rotate quickly. Describe them as dirty ice cubes, and all because these objects are a mixture of rock and ice, and when they cross the ice boundary, their ice begins to turn into gas. Non-gravitational acceleration, but also increases the speed of their rotation, and the faster these objects rotate, the easier they can break into smaller ones fragments. The pieces that break off also contain ice, and as they spin faster and faster, they break into even smaller pieces. The process continues until you are left with very small, rapidly rotating objects. The fragmentation cycle helps explain why dark comets are often so tiny, but it could also mean that there are more of them than we currently know. Studies of dark comets provide new insights into the distribution of ice in the atmosphere, the solar system, and its potential paths to near-Earth space also raise intriguing questions, such as how much ice remains hidden in the asteroid belt, or whether dark comets could play a role in delivering water or organic materials on the ground. One of the most important points is that dark comets can make up a significant part of the solar system, near-Earth objects. If this turns out to be true, it may mean that our understanding of the population of near-Earth objects and their potential risks to our planet, far from completing the processes that form dark comets from sublimation to fragmentation, may become a major factor in the evolution of icy bodies throughout the solar system. Fortunately, nowadays scientists have the opportunity to combine advanced modeling with observations that, eventually, they may shed light on a very elusive class of objects that may provide clues to the history of water and life on Earth. That's for today. So hey, if you've satisfied your curiosity, then like this video and share it with your friends. And if you want more, just click on these videos and stay informed.